zero test, he has assigned as exercise. Let's prove it, but let's talk about it. What he says is that sigma A and B a convergent series of real numbers. It is convergent. Then we must have limit is equal to 0. We have to prove it. To put this another way, if limit is non-zero or divergent, then the series is divergent. So, first Cauchy criterion can be used to prove the series is convergent as well as series is divergent. If by any chance we can compute that sum n equals p to q. However, zero test can be used to prove series are divergent only. So let's prove it. So I am not going to prove the other side of this thing, is going back. Same thing. Zero test. So I am not going to write the test on the board, so I am going to prove it only. Corollary. Proof. What do I have to show? Let this thing be a convergent series of real numbers, then we must have limit n tends to infinity n equals 0. Since n going m to infinity, an is convergent, the sequence Sn is capital N now. Is Cauchy. The sequence is Cauchy. Right? Let epsilon greater than 0. Then there exists some, I don't have enough English letters. I like to
Keep pen reserved.
eh?
Keep capital N reserved.
Yeah, I want to say it. I put SPP going into infinity Cauchy. Then there exists n belongs to n such that n greater than or equal to m, and for each PQ P greater than Q greater than or equal to n, S P minus SQ less than epsilon. Right? In particular, you have to learn to write English. In particular, in particular S p plus 1 minus S cube less than epsilon for each cube greater than or equal to n. Sp plus 1 minus S cube, no, sorry, Q plus. For P, I choose Q plus 1. Thus, this minus this is AQ plus 1. What is this? What does it mean? That is limit I have for each cube greater than or equal to n mod of a cube plus 1 less than epsilon. That is limit n tends to infinity. Q tends to infinity. A cube plus 1 is equal to 0. So I have proved it. If the series is convergent, then limit of a cube plus 1 is equal to 0. So done. What is important is what we have shown is that if sigma a n going into infinity converges, then limit n tends to infinity, a n is equal to 0. But we have, if this thing converges, this is my IF, CGS I write for values, then this thing is equal to 0. By contraposition, if limit n tends to infinity, a n not equal to 0, limit n tends to infinity, a n doesn't exist. That is a n varies. If the limit is not equal to 0, or if the limit does not exist, then sigma n going into infinity derivates dt is isomorphic. So this is called, in this book he says zero test. In many other analysis books they call it nth term test. You look at the series, it is divergent, then you say, example, say sigma n plus 1 divided by 2n plus 3, chain going 1 to infinity diverges because limit n tends to infinity, n plus 1 over 2n plus 3 is equal to 1/2 and not equal to 0. There it is. One more example. Sigma n going 1 to infinity minus 1 to the n times n over n plus 1 diverges because minus the sequence, excuse me, minus 1 to the n times n over n plus 1. Diverges. No limit. Because lim sup is plus 1, lim inf is minus 1. Right? So, this way, you may discuss the convergence of the following series. So, this is kind of the first test you have done. So, this is divergent, this is divergent. Notice that. Oh, I cannot write that. You told me I did not prove that sigma 1 over n divergent. So, this follows from these two decisions came from zero test, according to the book. So you need to write the term zero test that you are using it. You want to copy down or all right. Over there we have written if sigma n converges if and only if this one, no? For each epsilon greater than 0, here it is capital N. Notice that sigma an diverges I over C n by 1 to infinity. If and only if, I double left, what is it? For each there exists
epsilon greater than 0.
there exists, say let's say prime epsilon 0 greater than 0, such that such that
Mode of sigma.
yeah, before that you need to say something. Such that again I will for rest.
For each n.
Go back to band.
Huh?
Huh?
Ada.
Now you know about me. That's that. What did you say, Buddha?
For each n,
For each n, we don't need greater than or equal to m because I wrote this way. For each, you said n, no?
yeah,
Has it written capital? Yeah. For each capital N belongs to, you said plus.
there exists P, Q,
Yeah, like this.
P and Q greater than or equal to n.
This has written Q. Upstairs, for instance, in Q, let me write this way, Q greater than P, greater than or equal to N,
Such that what of
sigma,
yeah, sigma
A, let me see that, N, A, N, N going from P to Q, no?
yeah, greater than, strictly greater than epsilon.
Good, some of you took more time than you should have taken. Anyway, finally you did it correct. So we are going to use that to prove that sigma n is 1 over n is divergent. Example. Let us show that. Sigma 1 over n like this. But I know the proof, no, so in your case, if you are starting from the scratch, you don't know, so I will say let epsilon 0 is equal to 1 half. Then greater than 0. So now what I am going to do is, before writing the proof, something must be clear to you. Now I write down, now let n belongs to Z plus be arbitrary. So I am going to find q greater than b greater than or equal to n, right? However, when I add, for 1 over n you don't need the absolute sign because it is positive, greater than or equal to 1 half. Assume that I proved it, but what is happening here? You have 1 over 1, 1 over 2, bingo, 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 plus somewhere you get here capital N. What I am going to show is that after that, q greater than or equal, q greater than b greater than or equal to n. So somewhere here I begin from 1 over b. Then I go to 1 over q. This block sum is greater than 1 half. Again here I will get another block. So this is true for each capital N greater than Z plus. No, I took n. If you take somewhere here, then again you get another block greater than 1 half. What we say is, for each n belongs to Z plus, you can choose 2 integers. That block sum is greater than or equal to 1 half. You start from here, this block is greater than 1 half. You start from somewhere, then you get another block greater than 1 half. Another block greater than 1 half. How many blocks are there greater than 1 half? Infinitely many. So half times infinity is infinity, then series is divergent. That's the idea. You get blocks of sum greater than 1/2 infinitely many. Therefore, series diverges. So now I have to somehow show let n belongs to be arbitrary. Now I have to show here. Let's begin from here. P can be equal to n. No? I choose Q. Let Q is equal to what? I have to write, no? I know this one, 1 over n plus 1 plus and so on plus 1 over n plus n. So I will write mine. P is equal to 2n. Oh, no. Q is equal to 2n. P is equal to n plus 1. Then it is clear that Q is strictly greater than P is strictly greater than n, and this one greater than or equal to this one 1 over n plus 1 is bigger than 1 over n plus n. Here 1 over n plus 2, that is also bigger than n plus n, plus all of them are bigger than or equal to n plus n. There are 1, 2, 3, 4 capital N terms. There are capital N terms here. All of them are n times 1 over n plus n. This is equal to 1. This is n times 1 over 2n. So, done. What this says is, no, from wherever you begin, 1 you have, if here is 1 over 1 plus 1, no, plus, how many times? 1 plus 1, if n is 1, 1 plus 1, 1 over 2.
That's it.
Eh?
That's it.
That's it, that is it. Then you get, so this one is greater than 1/2, for instance, this one is greater than 1/2. Then you get 2 plus 1, 2 plus 2, right? This block is greater than 1/2. Then you get 4 plus 1 to 4 plus 4. I mean, I am done. Proof is over. I am just explaining what is happening here. 4 plus 1 to 4 plus 4. This block is greater than 1/2. Then 1 over 8 plus 1 to 1 over 8 plus 8. This block sum is greater than 1/2. Like this you get sum bigger than 1/2. So many blocks. So the sigma 1 over n is everything. Right? So this proof is over by here. So what is happening, however, is if you are, let me see that I can draw. No, I drew it at the wrong place. I am now convinced that, because that is very important. Sometimes you prove things, if it is not close to your heart, you cannot use it. Here now, I proved the result and I am convincing. There are infinitely many blocks sum greater than 1/2. Therefore, sum must be infinity. Now let me erase this. So, if you have suppose you have this thing, some big vessel, and there is a water tap. My art will be very good. Okay. From here you add water to this thing. First you are adding, so water comes. First instant you send 1/1 water. First instance. Then 1/2. Then 1/3. This is water tap. Drops of water comes to this basket or vessel, whatever it is. So first, right away you put 1. Then 1/2. Then, according to me, 1/3 plus 1/4. Again, greater than 1/2. Then, can you see, if you are water you are sending to this thing, 1, then 1/2, 1/2, this water is enough to cover whole Sri Lanka. Infinitely many water. And another thing is very important about this picture. If a series is converging, suppose this one also has a tap from here. That is when you have negative terms. Positive terms you send the water by this tap. Negative water you send away from the vessel from this tap. So series is convergent means what? Both the taps are open. After some time, if you put your eyes here, if you are looking at it, water level, it does not change. Because water comes, if the term is positive, say suppose you have -1 to the n over n, for instance, this series is convergent actually. N going on to infinity, this is a convergent series. We haven't proved it, but assume. So can you see, let's see, the first time I will make it like this, otherwise you don't have water to send first. So if you are at -1, first time you send -1 to the 1 plus 1 over 1 water to here. Next, so you open this tap. Second, it is negative 1/2 you are sending out. 1/2. Next, you are adding water, sending water, adding water, sending water, adding water, sending water. When the series is convergent, what does it mean? If you look at the water level, it does not change for human eye. Then somebody will ask, would it change for a very sophisticated computer? No, again, what happens is, any man-made computer or whatever the instrument is sensitive for something, no? Not
Some range.
Yes, there is some range on which the thing is sensitive. For instance, when you are 100 meters race in the World Olympics, if you look at from our human eye, we say, oh, 2 people are tight. From the human eye, they ended simultaneously, same time. But from the computer, one person is fast. So regardless of how efficient the computer or whatever, regardless of how small or large the range is, if you look this way, water level won't change, but water level, some water goes here if it is like this series, plus terms and minus terms, water level remains the same according to any man-made human eye. Man-made eye. You see what I'm saying? That is the meaning of a series is convergent. Because water comes from this tap, water goes out from this tap. But you look at here, can you see? That's what Cauchy, the criterion says. After some time, no matter how many times you get, water level remains the same. That is what is happening. So, the convergence of a series is far more, complicated than we think. It's very complicated. That's why that grid, infinite grid, comes to work. There are so many like this. So, lots of fun things that little guy don't come. No? He doesn't come. No? Right? Now I have shown that sigma 1 over n is divergent, plus I have convinced you that because sigma 1/2, what about the series? What am I doing? Sigma 1/2 n going 1 to infinity. This series is divergent because if you want, you can find Sn. Sn is how much? N over 2. It goes to limit is infinity. In A-level method, you get Sn is n over 2. You add 1/2 n times. Sn is n over 2. Limit of n over 2 is infinity. If you want, you can add 0 test. Limit of 1/2 is 1/2. Which is non-zero. Therefore, by 0 test, it is divergent. What I am saying is, if you are adding 1/2 continuously, there will be a big flood in Sri Lanka if you are adding 1/2 water. So, that's why here you are adding 1/2 infinitely many times. So, it gets bigger and bigger and bigger. It's difficult to believe. Actually, when I was a student, I was so amazed. I was thinking sigma 1 over n. After a while, these numbers are so small. So how can it be a big thing? So, that's why if somebody goes to engineering, of course, there may be things that we don't know that they enjoy. Engineering is a different subject. But this kind of mathematical thing they won't say. This is amazing, So small terms. Yeah. Chair is on the way. Who's that? Okay, so actually this is amazing to believe. There is another way. There is a theorem that when I was at another university, I asked one lecturer why sigma 1 over n is divergent. He teaches pure maths analysis. He gave me from this test. Nobody understands however, when you show this way, it is very clear. You have to have the feeling in order to do maths and to especially to enjoy it. It's a very entertaining thing. That little boy, he comes with lunch and he doesn't come. I know he is intelligent, he can learn this. Not everybody can learn, understand this because of the rigor. So we have learned two tests now. Zero test and Cauchy criterion test. And I am assuming that we should be experts in convergence and divergence of series. You know this one, so sigma r to the n, or else a r to the n going from 0 to infinity. That is a plus ar square is equal to what? A over 1 minus r if mod r less than 1. You know this, don't you? And sigma ar n going 0 to infinity diverges if mod r greater than or equal to 1. So these two tests and that I am going to assume you know, because whether they are in the book or not, I am going to do all the series tests, because he is not giving the taste of series on the book. We know Cauchy criterion, we know zero test, we know this geometric series thing. You can prove this thing, no? Yes? A over 1 minus r. Because it is very easy, no? In my time, A level, I don't know, before combined maths, I guess, I left A level paper when they began combined maths. I mean, no maths, they were there. So, thereafter, I don't know what's happening. Let's see now what is next. So now, anyway, see, can you see applying zero test? You can show many series are divergent. Applying this thing, this is true, but not that easy to show. That is, for sigma 1 over n, we were lucky. That 1 over n plus 1 all the way up to 1 over n plus n greater than 1/2. Quite often it is not easy to use it. So, but it is a fact that now what? Here, let's see what is next. The sequence n1 does not converge to 0 as n tends to infinity. We know that sigma 1 over n is sigma 1 is divergent. That is clear now. What is the sum of n? Now suddenly he has jumped to n going 1 to infinity. So what is that sum? N going 1 to infinity 1. How much is it? Second line, we know that sigma n going 1 to infinity 1 is a divergent series. What is the sum?
Up to infinity.
Okay. Infinity. Because you had 1, 1, 1, 1, 1. If you had 2 terms, answer is 2, 3 terms 3, 4 terms 4, 100 terms 100. So n terms n, limit of n is infinity, sum is infinity. Convergence of series is different notion from convergence of sequences. Similarly, the sequence a minus 1 to the n diverges. Why? Sigma n going 1 to infinity minus 1 to the n diverges. Why?
It doesn't have a limit.
It from zero test. It doesn't have a limit. And in particular does not converge to 0. Actually minus 1 to the n doesn't converge to 0. Thus the series is also divergent. If a sequence n does not converge to 0, then the series n does converge to 0. I didn't read carefully. If a sequence n does converge to 0, then the series n may or may not be convergent. So we are on the fence if the limit is equal to 0. It depends on the series. For instance, we will soon see that sigma 1 over n divergent. We just proved it, no? Despite the fact that 1 over n converges to 0 as n tends to infinity. Then absolute convergence. I hope book has interesting problems that you guys can try. Otherwise, I will give a separate, not homework exactly, but list of problems that you should try and enjoy. Absolute convergence. Let sigma n be a formal series of real numbers. We say that this series is absolutely convergent if and only if the series sigma, absolute A. Absolute convergence means when you take the instead of A and absolute A. If that series is convergent, we say it is absolute convergent. In order to distinguish convergence from absolute convergence, we sometimes refer to the former as conditional convergence. We use that word. Conditional convergence means not absolutely convergent. It's convergent but not absolutely. So there are, this series, we haven't shown that, we will show it. This series converges. We will be proving, not today, no time, but not absolutely. Because convergence part I have to prove, okay? Will be proved. But not absolutely, because sigma minus 1 to the n over n going on to infinity is equal to sigma 1 over n into divergence. Right? So, as a result, we call this is conditionally convergent. Thus, sigma minus 1 to the n over n converges conditionally. So I need to prove that. So conditionally convergent means it converges but not absolutely.
You should put the
Eh?
bracket on the bottom side.
Huh? With absolute value it is not convergent. Without absolute value it is convergent. So we say it is conditionally convergent. Let me see. 2, 3 means we say that the series is absolutely convergent. If and only if the series O. In order to distinguish between Q of A, absolute convergence test. Let sigma n be a formal series of real numbers. It has, if the series is absolutely convergent, then it is also conditionally convergent. That proof is simple. No, furthermore, in this case, we have the triangle inequality. Proof C, exercise 7.2.4. Can you see that if a series is absolutely convergent, then it is convergent? That from that proof it follows. If it is absolutely convergent, if you use the Cauchy criterion, you get given any epsilon, there's some capital N. After capital N, no matter how many terms you add, sum is less than epsilon. So, without absolute, and this, if you have some not infinity but some other P or Q, something like that, if this one less than epsilon, this one definitely less than epsilon. So, absolute convergence implies conditional convergence, but conditional convergence does not imply absolute convergence. No need to write the proof, no, you can see it. The converse to this proposition is not true. There exist series which are conditional convergent but not absolutely convergent. So conditionally convergent series are entertaining and gives trouble. Absolute convergence are very easy. 3 moments. We consider the class of conditional convergent series to include the class of absolutely convergent series as a subclass. I don't know the way you have a class here. What is the meaning of class? Thus, when we say that a statement such as sigma n is conditionally convergent, this does not automatically mean that sigma n is not absolutely convergent. That's also true. If I say that I have 10 rupees, it does not imply that I have more than 10 rupees. No? Similarly, when you say absolutely convergent, it does not imply that it is not absolutely convergent. It may or may not. I wish to say that the series is conditionally convergent but not absolutely convergent, then we will instead use a phrasing such as sigma n is only conditionally convergent. This is the first time I saw. Anyway, he says like that, no? Sigma n converges conditionally. The last one I use, sigma n converges conditionally but not absolutely. That's how it is clearer, I guess. Alternating series test. So that is the thing, minus 1 to the n over n series. Let A and be a sequence of real numbers which are non-negative and decreasing, has n greater than or equal to 0 and n greater than or equal to n plus 1. Then the series minus 1 to the n is convergent if and only if the sequence A n converges to 0 as n tends to infinity. So from the alternating series test, minus 1 to the n over n converges because here A n is, if you forget about the minus 1 to the n, your A n is 1 over n. 1 over n is decreasing and the limit is 0. Therefore, by alternating series test, minus 1 to the n over n converges. So now 3 tests already, and I haven't proved that. Minus 1 to the n over n. So let's prove it next day. Today not enough time, unfortunately. I have to go. Yeah. So I will take some bunch of problem next day or next week. Almost forward.
Have you stopped the video?
Yeah.